which the disadvantage of the YouTube videos would be you can't search through the generated
Subtitles.
dialogue.
Yeah, that's right. You can't actually find that exact moment because of the subtitles. YouTube captures them. I wonder if there is a way. We'll have to look into that because it does actually capture your it does actually generate the subtitles. I just don't know if you can search through them.
Yeah, I know. I know you can do the YouTube streaming because my Chemistry 1 teacher did it. His name's Pete Nicely.
Yeah, yeah. I had messed around with it, the YouTube streaming instead of Zoom, and I think I had no preference, to be quite honest. I was actually using Zoom mainly because the school asked us to. And for the most part, it's fine. And I still have the same dilemma if I'm at home. I can't really Zoom or the YouTube stream either. It's just that it's just not quite working well enough with my inconsistent internet speed. Ironically, I think YouTube does a little bit better from my house. But
Yeah.
until I get better internet, I'm out of luck. I did get a kick. I got the email from T-Mobile that they're changing. Well, I have a rural internet plan with them, and they just added 5G, and they're telling me they can get me a lot better speed if I upgrade to that. Gets back to the same limit. There is a 50 gigabyte high limit, and once you hit that, you're throttled. And it's like, well, I'm hitting 50 gigs without too much trouble whatsoever. So 50 is just not enough. So I guess I'm not going with that route. I have weighed the facts. In theory, I could hit 2 of those, and technically that'd give me 100 gigabytes. But where the real interesting theory pops in is when I run out of data on both, at least in theory, if I set up my firewall right, I can get that minimum speed out of both and basically add it together. So minimum speed is about 600K. So in theory, I could never be lower than 1.2 with two $60 plans.
600. What is your normal internet speed?
It varies. So
Not
on
throttled.
the rural internet, it varies. So like right now, early in the morning, the reason it works so well on Zoom for you guys, for the most part, was I don't get a lot of people on the network at the same time. But typically, I experience slowdowns only when the internet is being utilized in my area. But even though I'm in a very rural area, we don't have a lot of towers, so there is often some throttling going on. And my account is unlimited in actual data, but it's limited in the speed. Like 8 o'clock in the evening, doesn't matter which day of the week, I cannot actually do anything worth a darn. I can upload videos for like YouTube, but if I tried to do a Zoom or anything like that, it would just buffer out and just crash.
Yeah. Geez. We've got like a scholars club going with one of the humanities teachers. It's like on Fridays in the evening.
Yeah.
Holy cow.
Can't do much, can you?
Not really. It does not work good at all.
No. No, I have a suspicion that, what they've put about the Starlink setup, how they're going to limit it based on the region. It seems like they're limiting the numbers of people who can subscribe based on how much data they can actually put through. So they are trying to shoot for 50 to 100 megabits per second at any given time. So they'll be interesting if they can pull that off. Because I'd be happy with 20 always. Because 20 is going to stream any movie I'd ever possibly want to watch. And I don't need anything.
1 megabit per second would probably.
Oh, yeah, yeah. The only reason I'd want 20 is to guarantee there's no weird buffering going on in the middle of your playing it. Because if you're watching HD off any of those, you kind of need maybe minimum of 5. But right now we can't do any of that. I don't need to. We got. I'm not doing this to watch movies, but Um, it really is so I can start contributing more code and put up with annoying developers. So it's gonna add to
Yeah.
my stress level. I don't know why I'm actually wanting the internet better, but all right. Well, let's get back to chemistry because that I know and I can do right now because I'm at the school. I have good internet, and we had stopped talking about our alkenes and how we came about these little numbers, but that's just going to change the suffix and put this number 2 in there, and we're going to do a couple, well, 4 problems to practice it. And I actually added one more to actually add to our names. So when we actually do name our alkenes, we are still doing that exact same thing where we want to find the longest continuous chain, but the difference now is that chain has to include that functional group or the double bond. So even over here, I know it's got to include this, it's got to include that, and even this triple bond, it's got to include it. So those have to be in the backbone, even if it makes the chain of carbons shorter. So even if I'm going to take this molecule we have up top and change it ever so slightly. I'm going to put the double bond up here. Now, before on this molecule, to get that longest chain, we would definitely go all the way across, and that would be a substituent. And down here to the bottom one, going straight across is still the longest chain. But we're going to modify our rules and say the longest chain must contain that functional group. So that's got to be in it. So it's just going to change how we do our backbone ever so slightly. Now, this side's pretty easy on here. And then going over, we're just going to get the longest possible chain. On this one, going down is making more sense. Now, do you see on the left, it wouldn't matter if I go up or down because I get 2 more carbons. I'm just going to go down just because. And this really is just a straight line. There's no substituents at all in that one. All right. Now, backbone is almost the same. We find it, but we want it to be the longest continuous chain with our functional group. When we number the backbone, we normally numbered it based on substituents. Now our priority is those double bonds. We want those to have the lowest possible number. So like on this one, I am definitely starting down here because that's where that double bond starts. On this next one, it's not as critical because I get 1, 2, 3 and the double bond starts, or 1, 2, 3 and the double bond starts. Since the double bond doesn't call our shots, now our substituents do. And since there's substituents at this end is number 1. That same type of rule applies here because we have 1, 2, 3 or 1, 2, 3. I'm going to make this number 1 because I get to this substituent first. Because even though I have that hydrogen written out, hydrogen's not really a substituent. I could have just as easy drawn this molecule like that and just totally left the hydrogen off. You will see that on these skeletal structures, quite often they will draw out hydrogens if they're off of a double bond. This one we're going to number similar, but what throws people off on triple bonds, especially on skeletals, that right there and that right there, even though there's not dots there, those are carbons. So we have a carbon, a carbon, a carbon, carbon, and carbon. And it's really drawn this way because a triple bond will make a bond angle of 180 degrees because there's only 2 things off of it. And the last one, 1, 2, 3, 4, with that as a substituent. All right. Fortunately for us, nomenclature on these doesn't. The writing out the full name doesn't really change too many rules. The only thing we're going to specify different is we're going to have a suffix of E. So this one is just 3-methyl. And then we're going to put a 1 here to say where the double bond starts, pentene. Over here, 2, 3, dimethyl, hexene. This one, even though I have it drawn like cis was, where they were both on the same side, it's not really cis. And that's because I could have had that as part of the backbone. Since these two groups on that left side are the exact same, this does not have a cis or trans. It just happens to have a 3-ethyl off that location. We'll do this one now, even though it's kind of out of order, but it's 2-methyl or 2-ethyl. One butene. And this one, even though it's a triple bond, follows the exact same rules. The only thing that changes is the suffix. This is 2-pent-ine, Y-N-E. All right. And the only one of these that would have ended up with a cis or trans is this molecule up here. See how that double bond, if we actually were to expand on just that double bond, on this left side, I have an ethyl and a methyl and just a hydrogen. So these are two distinctly different things. And over here, you see how it's a methyl and then this CH, CH3, CH3. So we have two different groups on this side of it as well. Since both of them have different groups off there, that double bond definitely has a cis-trans orientation. Just it's not drawn to actually show you that. It's drawn to make it easy to draw. But technically, if I were to do this the right way with like Marvin, and what I mean by the right way with Marvin, if I actually type in that name, 2,3-dimethyl-3-hexene, it's not going to draw us anything at all like that. This is going to give us much more of a skeletal drawing. And you see how it did this little weird dash line? It's because it knows it needs to be cis or trans, and it just arbitrarily chose one, but the dash line's to tell us it could have been either one. But I can change that if I change it. I've now made this structure a trans bond, and if I ask for Marvin to name it, it's actually gonna, well, that's right. So E does mean the same as trans. It's just a different way of giving the names when you have more than one double bond. But Marvin knew that it was supposed to be a cis or a trans. Matter of fact, if I type it in with the name, and I'm going to do this one different, so I'm going to leave that name in there and change this to cis. You'll see it draws it where that backbone is wrapped around on itself.
Well, this is kind of an odd question, but did the chemistry notation come before the gender notation?
I would imagine this chemistry notation is newer, but based on similar ideas. What did you notice that you were asking about?
Cis and trans.
Oh, if they, so yeah, on the basic Latin there is similarities, but it really is on the true base of those words rather than anything else.
Yeah, I figured it'd be a little odd to come up with naming, what's the word here? Naming conventions based on organic chemistry.
Well, and we have some words that pop up that would seem to be a little bit insensitive to some of the current terms, but they're not meant to be. Yeah. But I don't know. It's interesting, but it's based on the original Latin and what they meant.
Yeah. I see.
Okay, well, I'm not going to I don't need to close that. Going back to this thing. All right, so we see that these functional groups change the numbering ever so slightly in how we actually name the molecules. We're going to look now at different functional groups. So all the ones that could possibly change all this. And it turns out there's quite a bit. Now, actually, we're going to come back to this. There are quite a bit. Like all these here on this page actually have the alcohol functional group. An alcohol functional group is just an OH where the OH is still intact. And it doesn't matter what else it's connected to, but the alcohol is a pretty common functional group. Now, in every single one of these, the alcohol will ever so slightly change how we give it a full name. Now, what I mean by ever so slightly, on this molecule and this molecule, they are named like alcohols, which is why they have an OL in their name. Ironically, neither one of these are actually what we call systematic or IUPAC names. Not directly. I mean, serine has an IUPAC name. Matter of fact, that's one I can put into Marvin here, and it will draw it. And ironically, it put the stereochemistry in there properly because that's how it actually is in the body. But if I ask it to name it, I think it will give me the IUPAC name. Yeah. So it's giving me the proper naming. If we were to learn the full rules on how to name a molecule, that's what this thing would be called. And see how the last name is propanoic acid? Well, the propanoic acid part of it is just 3 carbons, and the end location is an OOH. So that functional group is considered to be more important, and it's named based on that. And then if we go back and look at it, you'll see there's a hydroxide and an amino, and they're listed as if they are substituents. So there's the hydroxyl and there's the amino. You notice how it's got the 2 before the A goes before the H? All those work in. So we have this weird problem with functional groups. Certain functional groups take priority and they call the shots on the names. And when they're on there, the other functional groups just get turned into substituents. Now, we're not going to learn how to do any of this yet. So actually adding the order of the functional groups is like the next part of organic chemistry. Right now, we're just wanting to focus on identifying them. So we're going to actually look at charts like this and make sure we can identify them. Now, there are some we are going to name. We are going to learn how to name alkenes, and we are going to learn how to name alkynes, because we already did. And technically, up here at the true top, there should have been alkanes with an A, and that's just carbon-carbon single bonds. And we learned how to name those first. But we will be naming alcohols, but pretty much nothing else. All the rest, we just want to be able to identify them. And the function group that's in the red, the part of the molecule in the red, is what makes that function group what it is. So ethers really are just oxygens that are surrounded by different carbons. And the R does just mean a carbon. It's at least a methyl, like a CH3, but it can be anything else. It can be really ridiculously complex, it can be really ridiculously simple, but if the oxygen is between 2 different carbons, that is an ether functional group. Aldehydes are always on the end because it's a carbonyl, which is that carbon double bonded to an oxygen, and then a hydrogen. But as long as they're connected to something like another carbon, you have an aldehyde. And the simplest aldehyde would just have 2 different H's on both sides. And you've heard of this. Ever heard of formaldehyde? That one is formaldehyde. Ketones, very similar to aldehydes. But instead of having an H on one side, it definitely has carbons on both sides. And this name they have listed over here, that methyl ethyl ketone, That is definitely more of a common name. Normally, when we name something like this, see how that's 4 carbons? 1, 2, 3, 4. Remember how 4 carbons was butane? The proper name for this would have been butanone. The O-N-E says double bond to an O, and we put a 2 to tell you which one it's coming off of. All right. Carboxylic acids are kind of like aldehydes in the sense that they're on the ends, but instead of just being a carbonyl connected to an H, it's a carbonyl connected to an OH. You'll see these get simplified a lot just with a COOH. And that is just our carboxylic acids. They're all weak acids, all very similar properties. But if I rip off that H and put another R group on there, I've made an ester. And ironically, esters are kind of neat in the sense that they typically smell nice and they are made from carboxylic acids. And that actually leads to some really cool properties. Where do I have that? I have a table of a bunch of ethers. That's not where I want it.
Oh, out of curiosity, do you test Linux games?
Well, yes and no. We've done some coding for a interactive book type game system, and so I have a few of those on there testing different aspects of it.
I see. I just saw you had a lot of games installed.
Yeah, I don't really play much though. It really is test them, and then they're all simple beta versions of the games. And they're all kind of lame in my opinion. I don't know who plays those interactive textbook games, but they're kind of involved and detailed, but I'd rather just read the book.
Yeah.
All right, like on this ethanoate is another word for acetate. All of these esters can actually be made from vinegar as the starting ingredient. Now, we used to do this in a chemistry for health related lab where you actually made hand lotions. And in that lab, you actually made the esters to go in there to give them scents. And I always think it's just so darn awesome that ethanoic acid, which you know what it smells like vinegar. By treating it with propanol or propyl alcohol or any of these others, methylpropyl. So we can actually change the smell, and it really will smell like fruits. Now, it is kind of funny, you know how it shows an apple right there? That's one we've done. Not everybody thinks it smells like apples. Some people think it smells like bananas. And it's mainly because that particular ester is found in both those fruits. But the actual fruit has a mixture of esters in there, and the mixture is what you identify as the true smell. These will just be close enough, and they actually typically fool people, but they do smell like kind of nice. And I did this one a few years ago. It really does smell like you've cut wood. And these dudes do smell like a glue stick and Elmer's glue, almost dead on perfect. And one of my favorite ones to do periodically, Bacardi. So the rum, and it really smells like rum. And it was one of the first years I did the lab where we made the lotion. There was a group that actually made their hand lotion smell like Bacardi rum. And I thought, now that's an awesome one to use. You rub that on your hands, the cop pulls you over. Why do I smell rum? Oh, that's my hand lotion.
Oh, is this how they make all the artificial flavorings?
Yes and no. So these typically are, well, some of these are more stable than others. And some of them break down way too fast, so they don't get used. But the natural products, if it's a natural scent, it pretty much is an ester. But we have ones that get close. So that's what we typically treat. And really, what's so funny is I get the right ratio of these two with the banana though. There, it smells like banana. But if you ever had like banana flavored candy, it doesn't smell quite like banana, and that's because they're using something that's similar but not the exact same type of thing, just to get the smell a little bit more long living, I guess you could say. Yeah.
Doesn't degrade quite as fast.
Yeah, these actually, almost all of these actually degrade, gosh, just under heat. And unfortunately, all these in that middle row that are made off of vinegar, as they degrade, they'll start turning into a smell of vinegar. And that definitely wouldn't be a good flavor for your hand lotion. All right. So that's esters. After esters, we have amines and amides. Both of those have nitrogens in them. Amines just have the nitrogen attached off of at least one carbon, but could have as many as 3 carbons off of it. And amides have a carbonyl on one of those sides with the nitrogen. All right, how does this change our naming rules? Well, only slightly. When we actually find our backbone and it has one of those functional groups in there, the backbone needs to contain the functional group. And when we number our backbone, we want the functional group to have the lowest possible number regardless of where it is. All right, now that we've had the full rules, we're backing up a few slides, and we're going to actually do this 5 carbons with 1 triple bond and no rings. We're going to figure out all of the ways we can do this and name them. All right, so if I know it has 1 triple bond, I'm going to start with a triple bond. Easiest way to do this is take my other 3 carbons and just put them straight off there. And then we'll just have to put an H over here. Another easy way, I'll put 2 carbons on this side and 1 carbon over here. Now, I can't do 2 on this side and 1 over there because that's the repeat of this one, but there is one more way I can do it. It's going to be similar to this one where I'm going to put just an H on one side, but instead of putting these 3 in a row, I'm going to connect them in the middle. You see those? Turns out that's the only 3 ways to do this with that triple bond. All right, but now let's figure out our backbone at least. And on the first 2 we drew, it is just basically straight across. No substituents at all. But here we're going to have at least 1 substituent because we're going to get to this point and either have to go up or down, but it doesn't really matter which way we go. That one gives us 1 substituent. All right, so on this one, where are we going to number from, the left or the right? From the left. And it's a triple bond. This is just 1 pent ine.
I see.
And right below it, I'm still numbering from the left because I get to the triple bond at the 2nd position. So that one is just 2 pentine.
And then the next one would also, well, no, it would be 3-methyl, 1 pentane. No, that'd be, what is it? Butane.
It'll be butine. Yeah.
Butine. Oh,
Because
yeah,
the triple
because
bond.
3 bonds.
Yeah, but we number here because we want that triple bond to have the lowest possible number. So it is a 3-methyl. 1 butine.
I see.
All right. Now, we're just going to actually practice a little bit with identifying functional groups. When I give you a question like this on the test, I'm going to have certain functional groups circled. So what one did I just circle there?
Let's see here. So you've got a C, carbolic acid.
Carboxylic acid. This is an easier one. What's that one?
Hydroxide.
Or alcohol.
No.
Real easy. Dang it, I don't know. Suffix changes to an E, it's an alkene.
Oh, okay.
It's a carbonyl. On either side is a carbon. So it is a ketone. Similar, carbonyl, but it's connected to an NH2.
Aminocarbonyl.
Amide.
Oh.
Changing my colors here because I skipped this one. Carbonyl with an O, and on either side are just carbons. That is an ester. An NH, it's not near a carbonyl though. An amine. And technically we already did this one once. What's a carbonyl between two carbons? It's a ketone. And this one again, double bond.
An alkene.
Alkene. All right, let's actually look at some actual naming now that we've actually modified these rules and see how the function groups we've added are going to change the rules. All right, we've done alkenes already, so we know we want the double bond to be part of our backbone. Nothing on this side, so we go there, so it must go down. Which position's number 1?
Well, it would be the leftmost carbon.
Yeah, because that's where the double bond starts. And the only substituent I have is that chlorine. So I have a 1-chloro. One propene.
Wouldn't this be a trans or cis molecule?
Well, that's an interesting. So trans and cis applies to the carbon backbone, and the carbon backbone isn't cis or trans because that's not a carbon and that's not a carbon. But this does need that stereochemistry name because if I were to reverse that, these two are definitely different molecules. But you remember when we saw on Marvin, it used an E and a Z in front of it? This is where the E and the Z nomenclature would come in, but we're not talking about that here. So you would not be naming that shape on this one.
Well, isn't that just the same molecule twisted?
Yeah, but you can't rotate a double bond without breaking it. So these are two different isomers.
Interesting.
Now, this one is also properly allowed to be called 1-chloropropene without a number there. Why do you think that is? Propene
let's
only
see
having
here.
3 bonds, the double bond would have to start at the beginning. There's no such thing as 1-chloro-2-propene, because 1-chloro-2-propene is actually 3-chloro-1-propene. The propene priority is always at the 1. All right, how about this crazy one? Triple bond must
Oh,
be in
boy.
the backbone. Which way am I going to go when I get to here? To the right.
Right.
There are
So-
actually 2 substituents. That one definitely. Where's the other substituent?
Oh, probably the fluorine.
It is. How I drew it there, I tried to hide it.
Yeah.
And I probably
So
would
I guess
not
that
do
would be-
that because that could have just as easily been a typo, right?
Which that would make it fluoro, right?
Yes. So I have 1,
So
2, 3, 4, 5, 6, 7, 8. So what are we going to name all this together?
that would be octine.
Yep.
With so 1-methyl, or no, not 1. That would be. Yes, that's on the 4. So 4-methyl, 4-fluoro, octine, or 1-octine.
Why did I put the fluoro before the methyl?
Oh, alphabetical order.
Yep. All right. How about an alcohol being present? Now, the backbone is the longest carbon chain that the alcohol is part of. So it can look like a substituent, but I actually end up doing this to point out that it is part of that backbone. All right, what carbon do you think the alcohol is at?
Number 2.
It is. All right, the only thing that's going to change on this is the suffix. Alcohols, the ANE, or how about this? I'm going to do, on the end of it was definitely an E. That gets turned into an OL. So this is 2-butanol.
What is ethanol? What is the shape of ethanol?
Carbon, carbon, F, and all.
So very simple alcohol.
Oh yeah, yeah. And it's one of the few alcohols your body can safely process and turn it into something that your body can actually handle. Pretty sure 2-butanol. I don't think it's necessarily toxic, but it's not going to be good for your system. The only other alcohol that's kind of safe to drink is, I think it's isoamyl. Mainly because your body can't process it, but it still gets you intoxicated. Problem with it is it doesn't take much since your body can't process it. So you drink about 30 milliliters of it and you're drunk for about 20 hours.
Wow.
Wouldn't that be fun? You can buy that on eBay, by the way.
I don't know if that's a good thing or a bad thing.
Yeah, it's funny to read the CDC, not the CDC, the government researched it ages ago. And it was funny to read the articles because they basically had test humans. And, you know, 25-year-old female drank 15 milliliters of this, was feeling intoxication within the hour and was unconscious for 36 hours. Hungover drunk. All right. This one, the backbone is going just straight across because 5 continuous carbons. The alcohol is part of my backbone. And I just have substituents. So where am I numbering this one from, left or right?
Sorry, my microphone was off. You'd start from the left, yeah.
All right, so we know it's pentanol. That will be our backbone name. And we have methyls and iodos. It's going to be a dimethyl, though. So alphabetically, what comes first? We do not alphabetize by the dyes. Those are methyls. Methyls come after iodos.
I see.
Mm-hmm. Excuse me. All right, what is next? Oh, look how small that one got. Okay. But our alcohol is right there, so we know that's part of the backbone. Should I go up or over here?
Up or, well, over. It has the,
I can make that
you
part of
can
the
go all the way
backbone.
down.
Yeah. We have an ethyl and a chloro. Which one comes alphabetically first?
Chloro.
And where is it at? What carbon?
Number 3.
Yep, because that's a 2. So we have 3 chloro, 3 ethyl, 2 hexanol.
And all of these alcohols are solvents, right? Well, most of them.
Actually, we might be able to use this to actually do some other chemistry with. So, alcohols are relatively stable by comparison to many functional groups. So there's quite a variety of those that are starting ingredients in other reactions. But I doubt this one has a purpose in anything special. I don't even think it's going to make a good solvent. It's going to be too heavy of a molecular weight, so very thick, very dense. All right, next one. How are we going to number these guys? It is a cyclohexane. I have 3 substituents. Which one do you think is the number 1?
Let's see here. Well, we've got 2 methanes, or methyls. We've got 2 methyls and 1 chloro, so we better start with the chloro.
Well, chloro would be right if we did number by alphabet. We only number by alphabet when there are ties. So having this 1, 2, 3, and 4, I'll put those numbers 1, 2, 3, and 4, is an option, but wouldn't 1, 2, 3, and 4 give us smaller numbers?
Yes, that's true. Good point.
And that's why we number that way. So the alphabet didn't enter on this layout. Where they're at actually called all the shots, because that's the best way to get the lowest possible numbers. Now, when we name them, we will be doing alphabetical. So chloro is definitely going to come before methyl. I think I have just one more, but you'll notice it's a very similar structure. Just got an alcohol in place of where that chlorine is. You think we should have the same numbers?
Well, yeah, I would say so, because we don't need to, oh, yeah, I would say we would.
The weird thing on this is a higher priority functional group. This is not cyclohexane anymore, this is cyclohexanol. That defines that as the number 1 position. Isn't that weird? So chloro is just a substituent always, and so is the methyls. Alcohol is one of our functional groups, and it causes it to take priority. Now, what's interesting, you notice I don't say 1 cyclohexanol? That's not always used, because it's implied to be the number 1 position when we have alcohol. Now, what we're starting to see a lot more happening when we have multiple substituents like this. So, when it's 1, if it's just this, that is definitely just cyclohexanol. We're starting to see a little bit more in literature. When there's more than 1 substituent, everything gets numbered. So this is becoming a little bit more common. That looks terrible. I dragged my E.
Indeed.
All right. Technically speaking, we're done with this chapter now. Now, that is good, and it was intentional, because I know when you start working on the worksheets, you're going to have some challenges. Because even though we did a really good job of covering things, this stuff is a little bit harder to put into practice, because especially on this nomenclature, people get it really quick or they don't. And even those who get it really quick, when they go to apply it, they start to see that there's a little bit of tricks embedded into it. So it's going to give us a chance to go over and look at the practice on the worksheet. So we have definitely all day Wednesday. And in theory, we would have all of next Friday as well, because you don't actually have to start your test before class, obviously. I always have 2 people that do it like midnight Friday. They actually either stay up late or get up early and take it before the class even starts. So they do it Friday, early Friday. And it's always been the same 2 people. It's actually my other section, but I actually have people take it very early in the morning in the AM on Friday. But hey, each their own.
Do they do well?
They do. One of them's actually missed 1 point on all of the tests. Yeah. Yeah.
Well, maybe they've got work to go do or something.
I assume that's what it is. That was the nice thing about doing the test online. I'm actually seeing that what I would consider my traditional college students, the fresh out of high school type idea that are just mostly focusing on just school, they're taking their test somewhere in the evening, somewhere between 6 and 9 o'clock. Everybody else, you can kind of tell they're doing it based on work. And it's always like 15 minutes after the hour at a good time when work gets out, so 6:15. Or 6 in the morning, because they're taking it before they go to work. But yeah, you can tell. And almost everybody who takes it on odd times takes it at the same odd times all the time. But so starting today, I'm going to double up on my check into my emails, and anybody who submits worksheets starting today, I should get it graded and actually get some feedback to you relatively quick. And I don't think I think I'm current right now. I think the only thing I have right now is a couple things from my organic students, and that's good. Their grading their stuff takes a little bit longer. And I take that back, I don't. I am actually current, except for lab. So, but if you have questions, I'm doing videos on these. In theory, if there's one that you think I might have already answered, and there are some, especially for the worksheet 17, if you just search for that, like just cut and paste the question, put it into YouTube search engine, it's likely going to match one of my videos. Because that's what I'm doing on my description. I'm just putting the entire question in there. Should make it easy to search. And that would keep you from having to kind of sort through my channel, because there's hundreds of videos up there now. But
Yeah.
some of them are already done. I haven't had to do a lot of the problems with chapter 20 yet, but I'm sure I'm going to start getting more to it. I think I also changed your worksheet this year, so I've added more nomenclature questions. But the practice test is up and good to go, and I don't think anybody's looked at it in either section, but it's good to go. So I am going to stop recording now, but we should be in good shape.